Okay, in lesson 3.3, we're going to talk more about properties of logarithms. We had a few yesterday, or the day before, so you may want to go back and look at 3.2 notes and remind just kind of refresh yourself, I guess, on the properties from 3.2, because you will use those in this lesson as well. Before we start the logarithm properties, though, we do want to take a look at some of the properties of exponents. And the first one is the product property, and that's where you have a like base and you're finding the product, then you can add the exponents. If you're doing the quotient of like bases, then you can subtract the exponents. And if you're doing a power to another power, then you multiply the exponent. So all of those will also use in this. The properties that we're going to look at today for logarithms are the product property, which says if we have log base b of x times y, then we can, it's almost kind of like the distributive property. It isn't really distributing, but we take that, kind of combine that with the product property of exponents, and so now it becomes log base b of x plus log base b of y. So that product now becomes addition. The quotient property, log base b of x over y is equal to log base b of x minus log base b of y. So again, we're going from a quotient to a difference. And then the power property, when we have an exponent, in this case it's p, it's not considered simplified until we bring the p out in front and the p becomes a multiplier. So that exponent goes out in front and becomes a multiplier. That's pretty much the new information. Now we're just going to look at several examples of how we can use this. So in the first example, it says express each logarithm in terms of the natural log of 2 and the natural log of 3. Well, you can see that we have 54, which is not 2 or 3, so we've got to figure out how can we write 54 so that it has a 2 and a 3 in it. So actually what we're going to do is we're going to change that to a product, and preferably the product of primes there, because 2 and 3 are both prime numbers. So what I'm going to do is I'm going to take 54, and actually 54 is the product of 2 and 27, and I picked those even though we can use other numbers because I can write 54 as 2 times 3 to the third. Okay, 3 to the third is 27. And then if I look at my product property for my logarithms, which the natural log is just log base e, I see that I can change that product to a sum. And so I can rewrite that as the natural log of 2 plus the natural log of 3 to the third. And then I'm still not quite simplified because I need to bring the exponent, the 3 up here, needs to come out in front and become a multiplier. So I'm going to rewrite it, natural log of 2 plus 3 times the natural log of 3. And that's my answer. I now have it written in terms of the natural log of 2 and the natural log of 3. And that's all that we're wanting to do. So again, I took 54 and I had to think of how could I write that in terms of 2 and 3. And you can do prime factorization. You can try that out. Look at your different factors. And then see if you have any squares or cubics, and then you can maybe make it a sum, maybe make it a difference depending on what kind of problem you have. Okay, in part B, I have the natural log of 9 over 8. So for that one, I'm going to start out. I'm going to go ahead and write my quotient. That's a quotient, so I'm going to write that as a difference and say that's the natural log of 9 minus the natural log of 8. Now, it still isn't written in terms of the natural log of 2 or 3, but I do know that I can rewrite 9 in terms of 3, which would be the natural log of 3 squared. That's the same as 9. And then for 8, I can write it with a 2, base of 2, which is the natural log of 2 cubed. So now I have natural log of 3 and natural log of 2. I just need to bring those exponents out in front and make those multipliers so that I can write it as 2 natural log of 3 minus 3 natural log of 2. And that's my answer right there. I'm done. Okay, and then I've got a couple of, obviously I intended to have you guys do this, but I'll just show you the answer and you can kind of, at least for the first one, and 1B I will show you how to do that because that's a little bit different. But for 75, I want it in terms of 5 and 3. Well, 75 is 3 times 25, and 25 can be written with a base of 5. So I'm going to have the log of 3 times 25, which is 5 squared. Now there's my 3 and my 5. So product can be written as a sum. Log 3. All I've done is move the decimal point over one place. So I'm going to kind of counter that by dividing by 10. Because 54 divided by 10 is 5.4. Now I have a quotient, and I can rewrite that as a difference. And I already know that I can take 54 and write that with a 3. That's actually going to be log of 2 times 27, which is 2 times 3 to the third. And the log of 10, I can write it as a product of 2 times 5. That's how I get the log 5 and the log 3. So you got to kind of hang in there with me for a minute because I'm going to put these guys in brackets because I'm going to do some extra stuff with that. So I rewrite the quotient as a sum. And then let's see, again another sum, log of 2 plus log of 5. And as I'm going through, I'm going to do a couple of things. I'm going to take that log 3 to the third, and I'm going to take the exponent of 3 and put it out in front of log 3. And I'm going to distribute my minus sign. And that's going to give me log 2 plus 3 log 3 minus log 2 minus log 5. Well, what happens is since I have log 2 minus log 2, those parts will cancel, and that leaves me with log 3 and log 5. So 3 log 3 minus log 5. In example 2, we want to evaluate the logarithms again. We're just going to do some simplifying. And for part A, we've got log base 4 of the 5th root of 64. If I go back and look at lesson 3.2, we had something where we had log base b of b to the x power is equal to x. So if I can make my log base 4 and then write 64 with a base of 4, then I've got something to work with. So I've got log base 4. I'm going to rewrite 64 to the 1/5 power. So at this point, I'm going to take 64 and I'm going to write it as a power of 4. So that's the log 4, base 4. And then 64 can be written as 4 to the 3rd, and I still have that 1/5 power. Now I have a power of a power, just like I have in the properties of exponents. So I would have log base 4 of 4 to the, and I would take the 3 times the 1/5, and that's going to be 3/5. Well, in lesson 3.2, we saw that if we have a base and the number being the same, so we have a 4 and a 4 there, then the exponent itself becomes the solution to our problem. And so 3/5 is the answer. In part B, what we're going to do for these is we do want to simplify, and any exponent needs to come out front, in front of the log, or in this case the natural log. We're going to keep the 5 and just bring out the 2 in front of the natural log. So that's going to be and then 3 natural log e. And what we can do then is multiply the 5 and the 2. So I have 10 natural log e minus 3 natural log e, and we treat those just like they're like terms. It's no different than if I have 10x minus 3x, that's 7x, so this would actually be 7 natural log e. For the next one, we're going to do what is called expanding and then condensing the logarithmic expression. To expand an expression, what you're going to do is take, you're going to go from a product or quotient and you're going to change that to a sum or a difference. So let's try it out on example A. This one's kind of a simple one because you can see that actually we have just one big product here. We have log of 12 times x to the 5th times y to the negative 2nd. And we know that we can write a product as a sum. So we're just going to have a sum with 3 terms here. We've got a log 12 I have log 12 plus log x to the 5th plus log y to the negative 2nd. Now I know that if I have an exponent that needs to come out front, so that would be my next step, and I would say log 12 plus 5 log x, and then we have a negative exponent, so that's actually, when we're bringing that out in front, that's going to make that a negative or minus 2 log y. And so there's my answer. So I want to try that out for part B. Instead of a product, we have a quotient, so that means we're going to write this as a difference. So that would be the natural log of x squared minus the natural log of the square root of 4x plus 1. Now I don't want to leave that with a radical. I want to change that to an exponent. So I'm going to rewrite that and say that that's natural log of x squared minus the natural log of 4x plus 1 to the 1/2 power. Any exponent needs to come out front as a multiplier. So that's 2 natural log of x minus 1/2 natural log of 4x plus 1. And there's my answer. That's my simplified form. And you can see it expanded. It's stretched out. For example 4, it says condense the logarithmic expressions. We're just going to do the opposite thing. I'm going to write, I'm going to go from a sum or difference to a quotient or a product. So for A, I'm just kind of working backwards. You know, anywhere I see a multiplier is now going to become an exponent for my problem. So that looks like how I'm going to start this. So I would have log base 3 of x to the 4th to begin with for that. And then for the second term, I would have minus log base 3 of x plus 6 to the 1/3. If I can get it to right. There we go. That's close. That's supposed to be a 1/3. And then since I have I have like bases. I have log base 3 for both of those. Since I have subtraction can be written as a quotient. So now I'm going to just write log base 3, and then I'll have x to the 4th in the numerator, and the denominator, I'm not going to leave that the 1/3 power. I'm going to write that as the cube root of x plus 6. And that's it. That's my answer there. Same kind of thing for part B. Any multiplier is going to become an exponent. So that's the natural log of x minus 4 to the 6th power plus the natural log of x to the 3rd. And then a product or a sum can be written as a product and vice versa. So now I'm going to have natural log of these guys I'm going to multiply together. The one with the fewest terms is usually what I put first. You can put either order, it doesn't matter. I'm going to write it as x to the 3rd times x minus 4 to the 6th. The last thing here is the change of base formula, and that just allows us to use our graphing calculator and use the log button or the natural log button. Because our log button only is in base 10, so it's like, what do we do if we have a different base? That's the tricky part. What we do is we do the change of base formula, and that allows us to put it in any base we want by taking, and we put the x on the top and the b on the bottom, and those a's are any base. And in our case, and then on a graphing calculator, we would make that base 10. You can do the same thing with natural log. Natural log is just in base E. So for A, I have log base 3 of 5. I don't have a log base 3 button on my calculator. I just have a log button. So I would rewrite that as log 5 over log 3. And that puts them both in base 10. And then I would give the approximation for that. So you just literally type in log 5 divided by log 3. And I would round that to about the thousandths place. Same thing with B. In this case, I would have log 6 over log of 1/2. And yeah, you can put log of 1/2 in your calculator. You can either put it as 1/2 or you can put it as 0.5. And then you would also give an approximation.